Hello everyone. So we have been solving NJSLA Algebra 1 questions on quadratic functions, features, and solving quadratic equations. So one of the question here is on the screen. These arrows or these lines, I just draw it to separate the intervals. So it is original question definitely without those orange lines or red lines you considered about that, okay? So you can pause the video and you can read the question first. So one of the common question on quadratic functions, where the function is increasing and decreasing, where the function has positive and negative values. But in this question, I think it is not asked, but in this question, ask where are the intervals that function increases and decreases, okay? So when it asks intervals, it can be a bit challenging for the students, but the starting point or just like the point that we need to consider is uh, the intervals we need to look for on the x-axis, okay? So intervals we need to look for on the x-axis, which is intervals we need to look on the domain. What I mean to say that actually those vertical red lines I put on purpose, okay? You see here vertical red lines, I put them on purpose to separate intervals into just like some pieces, whole interval into some pieces according to given just in these are the intervals, okay? So we remember these intervals from where we are solving one variable inequalities, okay? Do you remember just most probably you remember that from middle school also. So if we have a let me draw just straight line like this. If we have a number line, okay? If we have a number line, here is in the middle, 0, here 1, here 2, and it's going this side, okay? When we call it infinity, it's going this side, like -1, -2, it's going to negative infinity, okay? So if there is a solution for any inequalities, for example, we say like x plus 2 bigger than or equals to 5, okay? So while we are solving this type of inequalities, what we do, we subtract from both sides, okay? Then we say that x bigger than or equals to 3. So when we say x bigger than or equals to 3, we can show it like this, but it is understood. But sometimes we need to show it on the number line, okay? When it comes to number line, we need to find just 3 on the number line, and we need to select those numbers which is greater than 3. Okay, well, what kind of numbers are bigger than 3? Like 4, like 5, like 6, okay? So when we plug in place of x, this inequality must be correct. Because of that, I need to shade, right side of the tree, since there is an equation here including 3 as well. So this type of inequalities and this type of just showing on the number line, we studied this. Actually, this is the interval, okay? We call it interval. Why we call it like this? Because writing all numbers which is bigger than 3 is not possible. I cannot count them even because infinitely many numbers are there which is bigger than or equals to 3. I cannot just count them. Because of that, I write either this way, like x is bigger than or equals to 3, or I write in a way that from 3, which is quadratic bracket, 3 is including till infinity, okay? Maybe this one is not studied in algebra 1, but in the future, in further mathematics, like in algebra 2 or in pre-calculus, you can see this type of also symbols, like open interval, like closed interval symbol, something like that. Even you say x is equal or x is element of this interval. I don't want to just like confuse a lot, but what I did here by putting those red vertical lines, I divided this intervals into some sections, okay? For example, this interval here, let me just shade it. This interval here, which is x less than what? X less than 0. Okay, x less than 0. What does it mean, x less than 0? Any point in this interval, if you choose, the x component will be less than 0. For example, here, this point is negative 2 and 1. This point is negative 4 and 4. Okay, negative 2 comma 1. I don't just consider what is the y value, but I consider x value, okay? As you see in these points, for example, this point negative 5 comma negative 2, okay? So all x components here, all x components here less than 0. Because of that, this interval, we call it as less than 0 interval. So when in the question says x less than 0, x between 0 and 2, x between just 2 and 4, x bigger than 4, we need to know where to look at first. That is the important part, or that is the very important thing that you need to consider it. If you don't know where to look at it, just we may not know it, okay? So now yellow highlighted just region, you see here, yellow highlighted region is x less than 0 region. Because intervals define according to where x is there, where x is. Okay? We should not define interval related to y value. Intervals define related to x. Because of that, the yellow interval is x less than 0 interval. Okay? So let me use my highlight and I will use blue color between these two. Here, in this interval, in this blue interval, as you see, x is between 0 and 2 because all x values here between 0 and 2, whatever you choose it, because this point is on the x-axis 0, this point is 2, this point is 4, which is not written on it, but we guess it because like 1 2 3 4 or 1 2 3 4, it's going like that. Because of that, this interval is interval which is x less than 2 but bigger than 0. Okay, so when I see x less than 2 bigger than 0, I need to see this blue interval. And I need to see the part of this whole parabola in this blue interval, which means that I need to see this piece of the parabola, okay? What is going on with this piece of the parabola in this interval? Okay? Then let me use my highlighter again. Now I will use pink color. There is another interval here, means between these two, again, vertical red line. So this interval is when your x is in this interval, when your x is less than 4 but bigger than 2. How I understand that? Because this vertical line is x is equal to 2 line. This vertical line is x is equal to 4 line, okay? Or this vertical line is x is equal to 0 line because passing through 0, 2, and 4. And the remaining interval, which is not shaded yet, I will shade it with a green color. This interval is when x is bigger than 0, okay? Any point in this interval, if you choose, x will be bigger than 0. Okay, you can try it. X bigger than 4. X bigger than 4 interval, not x bigger than 0, sorry. Because it is 4 here. Okay, so when any question is given in this format, we need to define the intervals first. Then we can check it whether our function is increasing and decreasing on that given interval. Okay, now tell me, on yellow region here, what's going on to quadratic function? Quadratic function is in this shape, okay, n shape. When there is an n shape of quadratic function, to understand increasing and decreasing, we already just like discussed this. We need to move from left to right. Then we need to check any specific point while I'm leaving, when I'm moving from left to right. Let's assume that very far left, the point is this. When you're going a little bit right side, the point is coming up. When you go a little bit right side, coming is point is going up, going up. So when you're moving left to right, x values, x coordinate moving left to right, what happens to point here? Okay, first position, second position, third position, fourth position. So points are moving up. When points are moving up, we call it the function is increasing. We call it function increasing. So points are moving up till the point of vertex. After vertex, what's going on? Still you move right side. Now level of the point, level of the point going down. Okay, when you are moving right side, level of the point going down, which means after this x of symmetry, after this x of symmetry, after this x of symmetry, sorry, I couldn't make it straight line, but you know, assume that it's a straight line, okay? After this x of symmetry here, what is x of symmetry here? X is equal to 2 line. After x is equal to 2 line, your points are going down, which means that your function is decreasing, okay? Your function increases here, your function increases here, direction is up, because when x going to left to right, okay? Left to right. So increasing and decreasing, you need to think in this way. Some students may think that, okay, sir, just when we move from right to left. No, we don't move left to right to left, because when you move left to right to left, from positive x-axis, we are going to smaller x-axis. So it will not define us how, or just like y value increases or decreasing. So increasing and decreasing of the function means we need to check the just y value of the function, whether it is increasing, decreasing, depends on x value. So because of that, x we need to move from left to right. When x is moving from left to right means start from very left side and go towards right side and stay on the graph, stay on the graph and observe that what is going on the values of or level of the graph, okay? If level of the graph increases first here, and go on the green dots, I am here, first position. When I come to second position, little bit right side of the graph, so the point is going up. Little bit right side of the going up, okay? It means that till here, like from negative infinity till point 2, very far left is negative infinity, till your x of symmetry, your function is increasing, okay? Then after x bigger than 2 values till infinity, your function points level decreasing. Okay? So in this context, we need to check. In this context, we need to check all options. Okay. So let's check the options. Now, after understanding this, definitely this is so easy. X less than 0, function is increasing. In yellow region, yeah, function is going up. X less than 0, function decreasing. No. F of increasing between 0 and 2. Yep, in the blue region. Between 0 and 2, f function is increasing again. Decreasing, no. F increasing between 2 and 4. Between 2 and 4 in purple region. In purple region, your function, the function is going back down. So it is decreasing. Okay? It is decreasing, not increasing. And here in the green region, function is again continue decreasing. Okay? So after understanding the context, the function increases or decreases, you can do it. You can do it easily. Okay? So please try to watch some more videos about increasing and decreasing quadratic functions. Actually, this chapter is um, more wider when you study further algebra, like pre-calculus or algebra 2, not only quadratic functions given us, maybe cubic functions, some exponential functions, in the future logarithmic functions, maybe trigonometric functions. You will study a lot of functions and on which interval functions are increasing and on which interval functions are decreasing. So we need to identify it. So the basic information or basic knowledge we need to obtain to get the intervals where the function increasing and decreasing. I hope you enjoyed the video. Um, I just like prolong the video a little bit to explain how we should understand increasing and decreasing issue. So thank you for watching.